Well, hello everyone. Welcome back to our monthly research seminar. It's good to have you with us. For the ever-shrinking pool of attendees I haven't actually met before, my name is Dave Lamb. I'm the Chief Scientist of Food Agility and I'll be your MC. I'd like to take the opportunity to acknowledge the traditional owners of the many lands and waters on which we all live and work. I'd like to pay my respect to elders of all of these lands and waters, both past, present and emerging. Now, for those of you who are still unfamiliar with food agility, and I expect it's not many now, we're a CRC dedicated to unlocking the power of digital to transform our agri-food sector. Now, just before I introduce our speaker, a few points of housekeeping by way of reminder. We are recording the session and ultimately we'll make the recording available to you. So we do welcome questions. Please fire them in during the presentation. Using the Q&A tab located at the bottom of your screen. Don't use a chat tab, I'll keep an eye on it, but please don't use it. I can keep my eyes on the presenter myself. Now, it's not possible for you to ask questions of the presenter directly, but I'll happily retail them through the presenter at the end of the presentation. Okay, and of course, if you have any burning desire to follow up with the presenter at the end of the seminar, that will provide the contact details in the slide as well. So now to the seminar topic. How often should you check the weather or allied environment conditions? There's little data available for Australians, but a US study of smartphone and tablet users back in 2017 identified the highest usage age group, that's the 18 to 29-year-olds. 38% use smartphone or tablet apps to check on environmental conditions, predominantly weather and pollen, for example, with only about 9% of that age group saying they won't use it. Now, interestingly, compare that to the 61 and older age group, where 15% use these sort of apps regularly, but 21% say they won't use it. That's interesting. A review by Diane Apps on 2022 global app usage found that 91% of app users access apps at home. That's not a surprise. 72% of us use them at work. 63% use them while shopping. Interestingly, nearly 80% of us also use them while watching TV. Says a lot about what's on TV. What does all this mean for the future of daily environmental reports? And incidentally, I should add that mental health advocates suggest that when it comes to online dating messages, you should be checking your online dating messages regularly, but not so often that you become obsessed with it and allow it to affect the rest of your life. When it comes to environmental reports, maybe if we spend a little bit more attention to daily environmental reporting, that may help improve the rest of our life. No doubt we'll hear a bit about that later on as well. So it's with great pleasure that I introduce you today's speaker, Dr. Beryl Morris from Terrestrial Ecosystem Research Network, or better known for many of us as TERN Australia. Beryl's the director of TERN Australia, and it's a national research infrastructure under the Australian government's NCRIS program. Beryl's career, quite long and quite fruitful, has covered public and private sector executive roles and directorships. She's been the CEO of several companies in life sciences area, provided strategic leadership in the tertiary sector, designed and implemented complex national science communications programs, commercialized technology, but has also found time to author some books and papers on a whole range of topics, including science, education, and management. So it's a privilege to have Beryl with us today, and I look forward to hearing more about the question, will we ever check a daily environmental report as we do with the weather? Welcome, Beryl.
Thank you so much, David, for that really great welcome. I don't think anyone's ever read my bio before, so that's a newbie for me. It's really interesting. David pointed out that TERN is part of the National Collaborative Research Infrastructure Scheme, and we're actually in a related ecosystem to the CRC Food Agility. We all belong to that science and innovation ecosystem where we're quite well put together, which means we should have a lot of things to share. I'm going to share my screen, in fact, with you right now, so that I can tell you a little bit more about TERN. And I'm going to wander all over the place because TERN has been going since 2009. and it does a lot, and yet it has so much more to do. So what we're trying to do is monitor Australia's environment 24/7, 365 days a year, so that we can help with ecosystem research and decision making, and help Australians prepare for a better future by having enough information about the environment that allows us to predict the cumulative impacts of developments. And there we go. So I'm just going to, since we have already acknowledged country, I'm going to tell you that I'm from the Jabukai country, and in the picture behind me you can see some rainforest. In fact, this is the area of the Bama people, the rainforest people. And in TERN, we have got many partners. Apart from the funding that we get from the Australian government, we also get funding from a number of state governments, and we couldn't exist if it wasn't for the federation of so many different generous institutions and individuals across the country. But isn't that the case with all of us? So what do we do in TERN? Well, I've said that we're monitoring ecosystems. The big selling point is that we're monitoring change over time. We're quite unique in that. Many people go out and do monitoring, but they don't necessarily have a time series. And interestingly, we are doing it regardless of land use. We are interested in everything from coast to coast in every direction and how it changes. In fact, land use changes all of the time. So in the little pie chart that's over here on the left, there's a little tiny slither in here of minimally used land. It's only 15%. And then grazing land, which is mainly rangeland and dryland cropping, takes up 55%. Cropping 4%, forestry is only 1.7%. We want to understand what is happening in all ecosystems. And where do we do it? Well, we're doing it right across Australia. I mentioned that we started in 2009, but there was quite a long time just deploying things, working out the strategy for where you put something into the field to monitor it, because there has to be a lot of method that goes with it. We try not to compete with other groups that have got monitoring stations in place. So some of the gaps that are on this map are quite deliberate because there is another monitoring effort. We haven't quite got around to actually putting all of those onto our map to show where everyone else is. But we have our monitoring at 3 different scales, and I'll go into that one a little bit more in a moment. But what we're basically trying to find out is where and when things are happening in the environment, regardless of land use. So where is the change occurring and when is it occurring? And we can do that through our remote sensing type activities. Then we have the questions that we do on a more regional basis of trying to work out what is changing and the direction of the change, because sometimes the direction isn't always in a what we consider to be a bad way, and how much is it changing out there. And we have about 17 sites that we call our deep dive sites, others call them super sites, where we have lots of instruments and so on at those sites, so that we can understand why things are changing and what we might want to do in order to mitigate against that change. So all in all, it's a bit arguable as to how many sites we have, because we have field crews going out establishing things all the time. And so, I usually say conservatively, at least 800, but between 800 and 1,000 sites across Australia that are tracking the status of the environment and the history of change and the direction of change, so that we understand the dynamics. So here's a better diagram of what I was just saying, shown in a sort of a funnel type thing. So the continental scale monitoring that's at the big end of the funnel, is carried out through mainly satellites, where we take the satellite data from all the campaigns that are run by other countries, and we fish out that information that is relevant to environment. And when we do our regional scale monitoring, it's mainly field crews that are out there. Now that's really important because satellites are good, but they need a lot of validation of the data. And so our field crews that are out in the country, and we have several crews that go out across Australia, they're able to validate a lot of the imagery that comes off the satellites. And Australia is, TERN is often called the calibration validation runway to the world, because even the International Space Station validates its data off our Australian TERN sites because they are very well instrumented. We have a lot of information from the people that go out and say, okay, that grey saltbush comes up with this sort of pixel when you see it from a satellite image. And then the deep dive sites that I mentioned, which we also call super sites because they have a little bit of everything that TERN does. So we have a lot of instruments at those sites. We also carry out surveys at the sites, measuring trees, measuring birds, taking all sorts of documentation about acoustics, etc., at those sites. So on the whole, what we're providing out of all of that is open access to data for anyone in the world to use. And we also have the data infrastructure, which means that we're not only able to use it for the infrastructure for the data that we're collecting ourselves, but other people can put their data into the TERN data infrastructure. And we have a whole lot of different tools that allow them to ingest it into our databases. We also are the keeper of standards on how to do things. So we are setting up the standard monitoring protocols across Australia so that everyone is getting best use of the investment that they're putting into monitoring. We are under contract to the Department of Climate Change, the Environment and Water, DECU, I've got the new name right, to develop, to take what TERN has developed as its standard protocols and turn them into apps that can be put into the hands of anyone in Australia who wants to undertake monitoring in a standard way and have that data go into our repository so that it can be brought together and give us a fuller picture of what's happening across Australia. And then the instruments and so on, sorry, I should say under the standard protocols and collections, we have collections. We are a national herbarium. We have over 100,000 specimens of soil and vegetation that we've collected over time from the sites that we visit. They're different to a herbarium or a museum type collection, which is where specimens are all separated out according to taxonomy. What we do is store them in such a way that you can create an ecosystem on a bench. You can pull out soil and vegetation and the data that existed at a site at a particular time, and you can reconstruct without having to go into the field all the essentials of what that ecosystem was like at a point in time. And you could do a time series right there on a bench in front of you. The sites that we have across Australia, they're 800 to 1,000 sites. Not all of them are fully instrumented, but anyone who wants to set up research and leverage all of the monitoring that we are doing has got free access to our sites and can install experiments and so on alongside us. We have a relationship with a group that's called the Critical Zone Observatory, and TERN monitors the biosphere, the above ground type things, but the Critical Zone Observatory takes a slice from the upper atmosphere right down to the bedrock. And that's really handy that they are co-locating with the TERN sites, because there are many things that happen under the soil, like there might be seismic activity that causes a burp of methane or a little bit of release of groundwater to the surface, that without the instruments that the Critical Zone Observatory people are co-locating with us, we might misinterpret, say, a green flush as something, rain or something like that, rather than something that happened below the soil. So why is TERN so hopefully attractive to everyone? It's in the green here, it's our mission of providing long-term preservation and access to analysis-ready ecosystem data to anyone that wants it, whether they're researchers, decision makers, not-for-profits, people in other places in the world. We just recently assessed all of the users of TERN, and 1 in every 3 of our users comes from somewhere else in the world. And that is very important, because ecosystem, or the planet, is just one continuum of ecosystems. And so if you really want to understand what's happening in Australia, you need to be doing what we're doing in TERN, and that is linking with all of the other continental scale observatories in the world, so that we harmonise our data in the way in which we have standard protocols and so on, so that groups such as the United Nations, when it tries to do its reporting on Sustainable Development Goal achievements, can take data from any of the continental scale observatories and pull it all together and get a whole of planet type view of what's happening. So this is how we have our data set out. I know I'm spending a lot of time on data, but I'll get into the field in a moment. I thought it would be useful to show you that over on the left, we have the remote sensing data. We take in data that has been collected by governments in their surveys. We have a whole lot of various things like camera trap information, acoustic information, and we have flux towers that bring us information about carbon and water and energy fluxes on the surface. We have our survey monitoring, where we're principally looking at soils and vegetation, but some fauna. And we have model driven, mainly from our remote sensing activities, where we derive products out of that. And that all goes into TERN and goes through some processing tools and algorithms and models and so on, so that we can have all the data products that are available through the TERN web portal and available to any sector of the community, wherever they are. Oops, wrong there. So how do we manage the data? It's actually a three-way thing. It's all about the processes, the technical infrastructure, and the people that are doing it. So looking at the processes, there are all the things like data policies and procedures and guidelines and data sharing agreements and data management plans and protocols for ingesting it and protocols for publishing things and adhering to international best practice or established standards, whether they're Australian, world, or ones that TERN has actually developed and published itself. And that all sits on top of the infrastructure itself, and I'm not going to pretend to be able to go into this in any particular way, but it relates back to that first diagram I showed you, where we have a lot of different types of data coming in, and through the brilliance of our data people, we manage to make it available. And our systems are being duplicated by a lot of groups, and TERN has been the architect of the data exchange standards that are being adopted by the federal government. Oops. Okay. Only my screen would move on. Okay, the people side of it, you can't do research infrastructure without the people. People are research infrastructure. They're the highly skilled people that are the data engineers, the curators, the domain experts. And we also work alongside all of the people who are using our TERN infrastructure, who inform us about what their needs are so that we can develop the right, we monitor the right things for them, and we use the right methods in the way in which we collect data so that they are able to take it up into their models and their research. We have around Australia a fleet of what we call TERN regional ambassadors to allow people, no matter where they're located in the country, to be able to contact TERN. And we have continuous desktop support, an e-support system, and lots of other resources on the web to help people. And our providers, just to go over that one again, we have our own information that we collect at continental, regional and local scale. And then we also work with people who put their data into TERN, and we make it available to them. So they're researchers, they might be a PhD student, they might be a government agency, they might be a CRC. And the types of data that we've got are spatial data and point data and a whole lot of micrometeorological data. And we are getting very strong on drones at the moment. And just to show you a nice picture of that, drones are turning out to be extremely useful to us in TERN in filling a number of gaps, both in space and time. So they allow us to cover in gaps across the continent. They allow us to fill in gaps between what we can do on the ground with our survey teams and the reach into the satellite information. They allow us to do things more quickly as we revisit our sites and try to get that time series data going. And they're turning out with the increasing technical developments on instruments that we can mount on the drones to give us higher resolution. It's just a matter of keeping up with the technology for some of the things that we are monitoring. We're very, very happy with how that area is going. So where would you go to discover the TERN data? Well, we have what we call a discovery portal, and that will give you access to all of the metadata so that you can peruse it and work out what is fit for use. Now, it is easy to oversell TERN. You saw the map at the beginning where I showed you all the dots of where we were and where we weren't. I like to think of us as sort of a regional provincial library. We've got a lot of books on our shelves, so we have a lot of data sets, but we don't have every title in the collection yet. And by partnering with other people, there are good chances that we might be able to do that in time. And obviously, we work off the smell of an oily rag financially, covering a continent the size of Australia. Any uplift in funding as we go along would also increase the number of books or data sets that we can make accessible to people. Just want to take you through one actual site, and this is a really interesting one because it's right on the outskirts of Brisbane, just to show you that we monitor things regardless of land use. And the little red circle shows an area in the Sanford Valley, what we call a peri-urban ecosystem site. We're keen to monitor this because it actually is it has the effects of fragmentation. It has some urban development in it. It's had some farming activity. It has a little bit of the endemic vegetation still there. It has quite a variety of vegetation, in fact, and it allows us to study the impacts of different types of land use at quite fine scale. So when you drill down on this, and I don't know that you can see the legend that's sitting there, but if you read that and you look at all the coloured dots on that location, the site is operated for us by Queensland University of Technology. there's a lot of kit sitting there doing all sorts of different things. And in addition to the kit, there are we have citizen scientists who have joined us who use our apps to carry out very consistently bird surveys along a corridor. The students at Queensland University of Technology and some of the schools in the neighbourhood do fauna surveys, and it's got a lot of people participating in the site and a lot of kit at that site. So, and way over on here, at this point here, is a flux tower, one of the things that measures the carbon and energy and water exchange between the ground and the atmosphere. And here's a slightly different viewpoint where we've just marked out the transects of some of the equipment that we've got monitoring biogeochemical activities on that site. I'll just give that to you as an example of how those deep dive sites operate. So going from the deep dive sites to more of a landscape, a continent scale thing, what are we doing with the remote sensing? Because this is where everyone's got all excited with Earth observation and so on, and they think that it will replace so many other things that are necessary, I believe, in monitoring. So we're able to monitor vegetation health, and there are a whole lot of different attributes within that, soil health, and we also, in doing that, come up with best practice in protocols and how to collect the information that has become world best standard and brings us every space agency in the world to work with us. So some of the advanced products that we're deriving out of the remote sensing data, we have a soil and landscape grid of Australia. And interestingly, you see up here in this corner, I hope, what we call the TERN Soil Data Federator. There is so much information in Australia on soils, but it all lives in different places. And it would take decades to actually get it all into one place and change its format and stuff like that. But we've come up with a system where the information can still live where it has always lived, state government or a research institution or agricultural college or something like that. And using web APIs, we can federate that and we can inspect it, and we can pull out a lot of information that allows us to develop some of this information on soil. And so our soil and landscape grid of Australia is well world known. Not many countries have got such a lot of information about their soils at the scale. Ours is at 90-metre intervals, and it's a combination of laboratory measured data and field measured data, and we do a lot of data fusion and very smart types of things. This, I think, is one of our most emerging to be one of our most exciting things. You can see the dynamic map working here. This is showing you the change in soil moisture from 2021 to 2022. It's always up to date, and we can drill down into polygons within that to get soil moisture information. To get that soil moisture information, we put together a lot of different types of information from our cosmic ray Cosmos soil moisture sensors that send information continuously to satellites and then back to us. We have access to soil moisture probes, and we have access to information that's coming from satellites, and we have modelled information, and by putting it all together, we get this in here, which I think is good fun. And we hope to do a lot more of those so that people can have immediate, up-to-date information on things of importance to them. Doing these things often turns up nice additional information. So by doing the soil mapping, we actually find that we're able to map phosphorus. I don't know a great deal about this one, but I thought I'd mention it because there might be people who are interested in that, and I'd put you in touch with the right people. But I think everyone's really interested in what's happening with organic soil carbon. And so I just thought I'd mention some of the work that we're doing, where we're taking our flux towers, measuring carbon dioxide and water and radiation, and doing all sorts of things to come up with a proxy of organic soil carbon. And this is being taken up by lots of groups around the world, and it's working really well. And in fact, these are locations of TERN's flux sites across Australia, and the red stars show where industry has actually paid TERN to put a whole lot of flux towers in to monitor soil organic carbon in that transect from Queensland right down into New South Wales. And I think we're about to expand that one quite rapidly because the information is looking quite exciting. So we can also do soil nitrogen, because once you start playing with soil carbon, you finish up also understanding a lot about nitrogen. And one of the things that we have in progress at the moment is developing a drought forecast for Australia. It's not all of our own information, but I showed you the soil moisture map that was moving, and we have Bureau of Meteorology data, and we have some clever people who know all sorts of formulae and so on, and so they can forecast drought, we hope, soon, and that will be a dynamic map that people will be able to inspect. We have a world first in actual evapotranspiration because we have our flux towers to validate information coming from satellites, and by being able to use satellites in different orbits around the Earth, we're actually able to come up with something that is a no gap, 30-metre, all of Australia monthly. We can actually do it 6 daily, but the amount of data is mega, and we don't seem to have a user group that needs it daily, 6 daily yet. So we're going for monthly at the moment, of changes in actual evapotranspiration. And if you subscribe to our TERN newsletter, you'll find that we just published a story of the New South Wales water regulator that monitors people's water usage in cropping, that is using our actual evapotranspiration no gap 30-metre data to go down to property level and examine at the property level whether people are overusing their water allocation. So I can actually see quite a nice service going if people give us the locations that they want to monitor and give us an arc of those polygons. Then we would be able to send back information on the evapotranspiration changes in the areas of their interest, right down to property level. So we often have people who are concerned that we might be continental and their industry is just a local thing and our data is therefore not relevant. But we can help people take our data and scale it from either a site right through to continental and back again, just a matter of knowing what people's needs are. Just in case you thought it was all about soil, I thought I'd better mention some biodiversity. We have a lot of information that is happening in TERN that helps people manage biodiversity, and whether they want to do that at the property level or whole of continent. So TERN runs the Threatened Species Index of Australia, and this is actually used by the Australian government to meet its requirements under legislation. And so we have hundreds of people providing us with information which is kept very confidential of time changes in a very large number of threatened species. At the moment, we have mammals and birds and plants, and we hope to be moving through all the different taxa. Somebody always asks me if we're ever going to do fungi, but I think the next thing that's off the plate there are frogs. We also are doing a heap of work following rainfall gradients to predict biodiversity tipping points. So we have monitoring equipment as ecosystems transition into each other, and we're able to identify whether the ecosystems are retaining their resilience in the face of repetitive extreme events, etc., or whether those events are happening too fast for safe, flowering period of the vegetation to recover, and that then affects everything else in that ecosystem. Each year we bring out report cards, and you can get it at your house level if you want. If you go in and type in your house, you can find out how things across 17 different parameters have been changing, either at continental scale or state or local electorate, or as say house scale. We have school groups that use this information to monitor the area where the school is located. They're brought out at the end of each year, so they're a retrospective. We brought out 2020. Next year will be 2022, next March. We're also able to use all of our plots to resurvey them after extreme events to see exactly what the impact has been. And we produce a lot of material to make sure that people get access to all of our monitoring. I mentioned that the whole surface of the Earth is a series of connected ecosystems. I thought I'd read that somewhere. It was on one of my slides. So we are very tied in internationally. We even got a poster at the COP26 event last year in Scotland, where we were proposing land fluxes as a new essential climate variable. And we provide our flux data to a global network, and TERN is a founding member of what is called the Global Ecosystem Research Infrastructure, where we act as the 6 observatories at continental scale act as a single instrument monitoring the planet's land ecosystems. And we are ensuring that satellite missions are getting calibrated, validated, so that we get much better quality information. We have in TERN what are listed as the top validation sites in the world. So we are the preferred site. Now, we're funded from the Australian government principally, and every 5 years the Australian government remaps the sort of infrastructure that is needed to support research and infrastructure in Australia. And we were really pleased to see in the 2021 National Research Infrastructure Roadmap, which was released in April this year, that there was a lot of support in the roadmap, probably the first time, to support continental scale observing. But what the roadmap was saying was that there are parts of the continents that we're just not observing. No one's observing groundwater, freshwater, coasts, atmosphere, and that we need to develop a way of integrating all of the observing that's happening in Australia. So they're calling it a step change, that we can better respond to climate change and adapt by being able to bring all of the monitoring. So TERN does land ecosystems, but if it was pulled together with everything else, then you would get seamless integration, and of course you'd get cost efficiencies in it. So one wonders how far you would go with all of this, because there are just so many things that would still be untouched on the planet that we can't possibly afford to be monitoring, and yet they all have a confounding effect on everything else. I mean, the land systems that we monitor, we know that we need to understand what's happening in the oceans and the upper atmosphere and things like that. But I think that this is decades off. So what about a field-based observing network where everyone pulls together, and maybe, you know, there are mega sites that have got lots of different activities at those sites. So TERN is already doing this to some extent with other organisations. I mentioned the Critical Zone Observatory that's co-located with us. We're also the home of the Australian Acoustic Observatory, and we're about to be the home of something that's launching right this minute, which is called WildObs, which is a camera trapping observatory of Australia that's going to bring together all the vertebrate camera information and put it into TERN. So you can get a lot of value add by working together. An example is the high precision GPS receivers that are sitting alongside the seismometers that belong to Ozscope, another group that is like TERN, but they're below the surface of, and they, you know, novelly allow investigation of impacts to groundwater systems from natural earthquakes or human-induced seismicity associated with fracking. And the thing that we have to watch out for, though, in this sort of tidy desk approach of bringing together everything, is that sensitive instruments have their needs. So, for instance, our flux towers can't be confounded by things that will change air movement around them. The square kilometre array, which is growing in its presence across the Australian landscape, needs to have quiet, and it wouldn't tolerate the noise of some of the instruments that TERN is running. So it's an interesting concept of how you would actually bring the whole thing together. But it could be a really good way of getting the money to spread further, because you would presumably reduce overheads. You'd be able to take a whole lot of kit out. We've got a tower, a 90-metre tower in Tasmania that got blown down by incredible winds last year, and we need to replace it. And we find that we actually have to replace the bridge on the highway so that the truck can get into our remote site. So, you know, if that was a site that also had other equipment there, it might make it good for cost sharing, those sorts of things. So we would then be able to get national strategies that cut across a whole lot of organisations, and perhaps we would get better integration across all the different data sets and data products. So coming back to my original question, how long before we can have an evening environmental forecast? I think one of these shows an allergy forecast. TERN was actually very instrumental in allowing allergy forecasting, pollen forecasting in Australia to happen with the weather. We took our remote sensing information of when things flower and put together that information with medical people and so on, and they finished up producing a fantastic product that predicts hay fever days and gives pollen alerts at city by city level. It's not impossible to do these things, but pollen and allergy is one aspect. It would be really nice to do something like they have in the weather forecast, where you have a whole range of things that are being looked at, but they're looking at what I consider to be relative in weather forecasting, relatively simple things. When you talk about biological systems, they're extremely complex. So what we would need in order to get an evening environmental forecast is for all of us who are on smart farms, digi-farms, continental ecosystem observing, below ground observing, etc., to pull our data and work out what it all means when it's brought together. And that's going to be quite some time away, I believe. So, TERN, in conclusion, we're trying to constantly improve the quality of our data and all of the services that we provide. We try to keep up with the latest in infrastructure, but when you're on a journey to make long-term data available, you don't want to just adopt the latest toy that's, sorry, not toy, incredibly valuable scientific instrument, because you're not meshed with the data that you've already collected on a particular parameter. So there might be a new way to measure leaf area index, but you need to calibrate it back against what has been done in the past so that you can have long-term data which you're able to preserve for people to be able to use. There's nothing more frustrating than not being able to find the data that's mentioned in a paper because somebody has closed shop, their grant finished or something like that. So we need to keep making our data accessible openly and make sure it's quality controlled, because we think that this is what is going to enable others to be innovative. So thank you. And I'm going to be looking forward to working with you as you help us meet the challenge of the evening environmental forecast. Thanks, David.
Thank you, Beryl. That was a fantastic reveal, but also a really compelling call to arms. So we have time for questions, everyone, and I already have a few come in, a couple via SMS too, would you believe? So Beryl, first one, you mentioned something like 1 in 3 users of what's on offer come from elsewhere in the world, which I thought was a really fascinating observation. You mentioned continental scale observatories in other parts of the world. Does TERN have any interface agreements with those, or is it a case of the user go and find them? So
we used to do MOUs like they were confetti. We used to travel around the world with a attaché case full ready to sign to show that we were partnering up with all sorts of countries. But we've had the value of the global ecosystem research infrastructure, so that at a continental scale, we're each pulling together all of the different networks of observers so that we can then contribute as a one continent to simplify things. It's so much easier to do that culturally, and so one of the members of that global ecosystem research infrastructure is CERN, the Chinese Ecosystem Research Network. And we're at the moment trying to get a National Science Foundation grant in the US to work together to show that by having these combined observatories, we're opening up an entire new field of research to researchers. But of course, the data there is in Chinese, and the metadata is in Chinese, and some of the metadata translation is quite difficult on language. It's much better with numbers. So there are challenges out there in doing it. I should say that every time we have a webinar in TERN, we have up to 18 countries online at the time, not counting Australia. They come from far and wide. So there's a massive interest I'm not sure, there's a massive interest in the environment, but I think people do think Australia does its science really well, and they want to see how we're doing it. I think I lost track of your question, David. You might have to remind me a bit.
You nailed it, Beryl. Thank you. So speaking of suitcases of MOU, I've got a question from Mick Schaefer, our coup, who walks around with the suitcases of MOUs, I think. I'm sure he thinks that. Mick basically asks if you work with private data sets that you're only able to share with particular individuals or organisations, and in this case, do you have a specialised data sharing agreement that will ensure privacy of these data sets?
Hi, Mick. Really nice question. Of course we do. We as time has gone on, when we started, everyone said it's all open, but that meant that we didn't get access, we didn't know of a lot of data that was there. And so we have accommodated the things like sensitive data, we've accommodated commercial data, and we therefore have conditions under which people can put their data there. So for instance, at the moment, we're trying to make a new biodiversity module that requires us to access the bat call libraries, which are very commercial to individuals in environmental impact assessments and things like that. But we're only interested in an aggregation of all the bat calls. We just want to see whether there's a change in bat calls. So we don't care about the actual bat call. So it's a win-win, actually. The people who own those libraries intellectually are happy, and to put them in there, providing that they have some little walls that mean that if anyone wants to access them, they have to go to the data provider. So they're special instances, but the majority of our data is all open to people.
Thanks, Carol. Another question came in, this one through SMS. Now, this is my recollection. I think you made a comment along the lines of paying TERN when you were referring to the flux towers and then setting up of the networks. And you had a really nice photo of a trailer-mounted flux tower in the background. Does TERN offer access to hardware, rent, lease, or purchase, like flux towers, if you want to set something up on site, or do you really have to build your own and then offer the data that's generated?
Yeah, excellent question. Until the bushfires came, we actually had a little store of money where we were setting up a fleet of mobile flux towers for people to be able to access, and which we also could deploy in a case of extreme events. But that big extreme event of a 2019-20 bushfire went through and burnt quite a lot of our infrastructure. And so we redirected the money into getting our stuff up and going again. But we do have one mobile flux tower that we're moving around at the moment. Our equivalent group in the US, NEON, has a lot of these, and they're on a big trailer, and they've got every instrument under the sun, and you telescope up the flux tower. We've had a few issues with the telescoping flux towers though. So short-term mobile flux towers are good, but really tall ones, you have to watch the wind a lot, and some of the instruments can be heavy and cause them to pull down a little bit, which messes up your measurements. So the engineering is not quite there.
Okay, thanks, Beryl. I had a question here which I'm going to refine thanks to one that's just coming from Nathan as well. It's around the process for contributing data into TERN, and you mentioned there's a whole range of process steps. So part of the question is, who do you call? So can you give us an idea of how the process works, how the agent structure works, but also from Nathan, following on from the early question around commercially sensitive data, how do you consider or treat the confidentiality in these data, in the exchange and use of data? Yeah. So one is about data access, getting access to put data in, and the other one is following on Mick's question around commercial in confidence or and quality control as well in the data. Okay,
I'll start with that one. So TERN is not an independent entity. We have a lead agent, the University of Queensland, and all of our contracting is done by the University of Queensland, which means that we use all of the confidentiality agreements and things like that of what is considered to be one of the most commercial of the universities in Australia. So I think that works quite well. And sorry, just remind me again the other aspect. Oh yeah, who do you call? How do you do it? Well, you would be best off setting up a conversation with the lead of our data services and analytics platform, whose name is Siddhaswara Guru, or one of his team. Or you can contact me. Any email that goes through to TERN at uq.edu.au will find its way to the correct person to answer that. And on our webpage, we have an e-support email that Guru actually monitors himself. So there are lots of ways in there, and we're always looking for someone to talk to us, so please come and talk to us.
Well, there's a challenge, everyone. So look, thank you all for your questioning, and thanks, Beryl, for your really thought-provoking presentation. So feel free to reach out to Beryl. So Beryl's provided an email address. You said TERN at, what was your address, Beryl, again?
At uq.edu.au.
Excellent. So TERN at uq.edu.au. Now, don't forget, we'll be releasing a recorded version of the seminar in a couple of days. Now, keep your eyes open for our next seminar, everyone. That's Tuesday, the 16th of August. We'll be hearing from Dr. Julia Easton from Curtin University about our on-farm experimentation project. That's one of the very first projects out the gates, and it's been a long project, and it's come to fruition, and it's just being wrapped up as we speak. Also, I want to flag ahead to October 25th, 26th. So it's a lifetime away, I know. But once again, we'll be having our online research symposium. So for researchers, by researchers, and everything to do with research. Gnarly challenges and eureka moments. And yes, we will be building a new jingle. So we're going to need your support. We're going to need your 30-second grab on your smartphone, dancing to a funky tune. And we'll build that again like we did last year. So those details and the request for that will follow as well. So thanks everyone again for joining us, and we look forward to seeing you at next month's seminar with Julia. All the best.